Hello, Algebra 2 students. Today we are going to do section 2.7, use absolute value functions and transformations. Now, previously in the first two chapters so far, we've been talking about linear equations where the graph is a straight line, whether it's diagonal, horizontal, or vertical, it was a straight line. Today we are going to graph a different family of functions, and that family of function is called the absolute value function. And its parent function is f of x equals absolute value of x. We are going to graph the function on the grid to the right. The vertex of the parent function is 0, 0. And remember, that f of x is just a fancy way of saying y. We are going to plot the vertex. Okay? For every point x comma y on the graph, so is negative x comma y, meaning if you look at x, y, for another point, the opposite of x is true and y stays the same. And the axis of symmetry is at x equals 0. And I will point that out here in a bit once we graph it. So the easiest way to graph this right now to understand it is to make a table. Okay, so we have 0, -1, -2, -3, +1, +2, +3. We are going to replace each of those numbers for x that I put in the table back in this equation for x. So let's start with let's just put 0, 0 down. Now let's start with -3. The absolute value of -3 is a +3 because -3 is 3 units from 0. The absolute value of -2 is 2, 1. The absolute value of 1 is 1, 2, 3. Now we're going to plot the points. Left 3, up 3, left 2, up 2, left 1, up 1. And on the opposite side of that origin, right 1, up 1, right 2, up 2, right 3, up 3. And we are going to connect it to the best of our ability. There we go. And that is your parent function. The axis of symmetry, basically what it does is it is a line that, I'm going to put a squiggly line right here. It cuts the absolute value function into two equal halves. It's a mirror line. And so you want to just draw a squiggly line. We won't do it for all the others, but that's what the axis of symmetry is. So this is x equals 0, or your axis of symmetry. All right, so if you have colored pencils handy, especially two others, you can use your pencil and you can use two more. If you don't, you can still do these graphs, but you would want to label them. So on the graph, on the left, we are going to graph three following functions, each one in a different colored pen or pencil. And I will use the different colors. On A, we are just going to graph the parent, which we did above. So I'm going to go ahead and plot those points again. 0, 0, 1, 1, 2, 2. And so on. You can plot more if you want to. If you want to take the entire graph, you can. It's harder to connect them the farther you are, but I'll try my best. There you go. And what you want to do is maybe label it right here. This is y equals absolute value of x if you don't have a different color. I do, so I'm going to go ahead and put my colors there. All right. The next graph, notice there's a number inside the absolute value bar, and it's -3. And so we are going to make a table for that, and I am going to use green, and I'll make it the table right here. And it doesn't matter, just pick some negative points. There we go. And then we are going to plug in each of those numbers in here for x. Okay, so the first one, -2 minus 3 is -5, but the absolute value of -5 is 5. So the right side of your table should always be positive numbers. -1 minus 3 is -4, absolute value 4. 0 minus 3, -3. 1 minus 3, -2. 2 minus 3, -1. and 3 minus 3 is 0. Okay, and I'm just going to plot those points. And we are going to just start from the top row, negative 2, 5. So go left 2, up 5. Left 1, up 4. Stay at 0, go up 3. Right 1, up 2. And then 3, 0. Okay, let's see. I want to put another number in here. We want to so we can see the position change. So 4, we want 4 minus 3 is 1 and the absolute value is 1. So here's where you see the shift change. So go right 4, up 1. Some reason. Oh, I forgot to plot 2, 1. I just skipped it. Yeah. Okay, so here is this graph. Connect the dots. And then this is how this graph would go. And that would be y equals the absolute value of x minus 3. Okay, and now for the last one, I'll do that one in blue. Oh, actually, let's go ahead and answer the question. I don't want to just leave us hanging there. How did that particular graph that I plotted in green shift from the parent function? Well, if you notice, everything about it is the same. If you start here and you go left 1, up 1, if you start here, you go left 2, up 2. So it's basically like the same, I'm going to say slope, still is like a 1-to-1 ratio. But notice this one started the origin, the red one did, but the green one started 3 units in which direction? 3 units to the right. So it shifted from the parent 3 units to the right. Okay. I'll do the last one in blue. And we are going to do y equals the absolute value of x plus 2. And I will make a table right here as I have room. At least my tables look nice. So negative 4, negative 3, negative 2, negative 1, 0, 1, and so on. So we can start any direction. Let's use the top. So plug in negative 4 right here. Negative 4 plus 2 is negative 2. Absolute value is 2. Negative 3 plus 2 is negative 1. 1. Negative 2 plus 2 is 0. 0. Negative 1 plus 2 is a positive 1. And that's just positive 1. 0 plus 2 is 2. 1 plus 2 is 3. Okay, and we are going to plot. So go left 4, up 2. Left 3, up 1. Negative 2. Stay at 0. Left 1, up 1. Stay at 0, go up 2. And 1, 3. Well, you just see the pic. You just, and so on. So you can just plot this right there. Hopefully you'll see a pattern and a discovery. Okay. How did the function shift from the parent there? So hopefully you notice it went in the opposite direction, and by how many units did the vertex change? So basically you're looking at the vertex. So you go from 0, 0 as the vertex for the parent to negative 2, 0. So it means it shifted 2 units to the left. Right. And so what we just graphed was we graphed some shifting that happened inside the absolute value. So this is our equation, and this is super important. Oops, not that one. Well, that's important too, but that one wasn't the one I was referring to. So this right here is super duper important. And you'll see it this time for the first time and throughout every chapter. You'll see it in except chapter 3. You'll see it in chapter 4. You'll see it again in chapter 6, 7. You're going to see it all the time. The reason why you're going to see it all the time is anytime you graph and you see HK, H comma K is the vertex. And what we just graphed, H is the number that's inside the absolute value bar that's hanging along by the H. And by the x, sorry, and k is outside the absolute value bar. Okay, write a generalization to describe what effect h has on the graph. So hopefully after graphing the green and blue functions, you notice that h, if you have something like this, x minus h units to the right. Now, do you think, is that what you thought might have happened? I don't know, because when people think of minus h, they think of moving to the left, but it's the opposite. H is opposite. So h units to the right. If you have x plus h, like we did in the blue graph, you move to the left. So h units. H is just a number, right? So in part C, the 2 was the h, and in um, part B, it was -3. So, or 3, sorry, my bad, 3 units. All right. The next one we're going to do is shift outside the absolute value. So, and that is referred to as K. So we are going to use colors again. I'll use red for the parent. So I'm going to graph the parent again. That shouldn't take very long. Hardest part is connecting the dots for me, I guess. Okay. Parent. Next one can be a -3. Okay. So making a table, I'm not going to make a table. I'm going to show you what we're going to do rather easily. So we know H moves a graph right or left. Well, K moves it up or down. And I think hopefully you've guessed that maybe you have an idea. You do this in Algebra 1, but at the end of the year. If it's positive K, you move up. And if it's negative, you move down. Well, in this case, you have a -3. Oops, sorry about that. So you go down 3. So you start at 0 because you just have nothing inside the absolute value bar other than the x. And you know if you just have x, you start at 0. So you start at 0, but you go down 3. 1, 2, 3. And everything else stays the same pattern as the red graph. And it avoids making, or you avoid making a table. And time has been reduced for you. Oops. You can always make one, though, just to make yourself feel good. And the last one, it's a positive K, so you move up. So up, and this one was down. So move up 2 from the origin, and then your pattern would be the 1/1. And there you have it. So I guess we can answer these. So 3 units down, 2 units up. Write a generalization to describe what effect K has on the graph of y equals the absolute value of x plus K. So K moves it, the graph, up or down. Another way to remember which is which, remember how I said HK is your vertex? If you think of H is also refers to, well, doesn't refer to, but I'm going to say H is horizontal. And remember, horizontal is right or left movement, and H represents moving right or left. And then K would be the up or down one then. So K moves the graph up or down. If it's positive K, you move up. If it's negative K, you move down. So it doesn't change. It's not the opposite. It's only opposite for H. Right. Going to the back page of our notes is flipping, stretching, and shrinking. So we thought we were just done with H and K. Nope. Because if you went back to my circled, my bubbled in equation, we had an A there. And so this A tells you that you stretch, flip, or shrink. All right. So stretching and shrinking on the graph the three following functions, each one in a different colored pen or pencil. So starting with the parent. If on your homework today it tells you to sketch in the parent, please sketch in the parent. But if it doesn't, don't sketch it in unless you just want to for reference. Okay. Okay, the next one. So notice this time there's a number in front of the absolute value bar. So you could have a positive number, a negative number, and so on. So let's go ahead and we don't even need to make a table for it. We can just start picking numbers in because all you're doing is you're taking the number in the bar, making it positive, and multiplying by 3. So let's do 0. So the absolute value of 0 times 3 is 0. So same starting point. 1 times 3 is 3. So go up, right 1, up 3. We're not going to be able to fit 2, but if we would go right 2 and we'd go up 6. But let's do the opposite. Let's put in a -1 for the absolute value here. So the absolute value of -1 is 1 times 3. You don't multiply -1 times 3 and then make it the absolute value. You do what's in here first. So that would be 3. And it can't be negative anyway. It has to be positive. It has to be above the x-axis. So you go left 1, up 3. We just don't have room to go right 2, up 6. So we can just go ahead and at least connect it and see this is what it looks like. Right? And how did that compare to the parent function? Well, it has been stretched thinner vertically. So remember, vertical's up and down. So it is, I'll just put has, stretched thinner vertically and it's steeper the quote, I'm going to put in parentheses slope because lines have slope and absolute value function is not a line, but just the half of the portion is a line. I mean, although there's an ending point, doesn't continue forever. So I'll just say half the portion is a ray. That's a better word. So the slope is positive on one side and negative on the other side. So in this case, if I were to start here at 0 and then I go up 3 and right 1, the slope is positive 3. If I start here at 0 again and go up 3 but left 1, or my bad, if I started here and then go down 3, right 1, it's negative 3. So the left side of the origin is a negative slope and the right side of the origin is positive slope. So that's what the 3 told us. All right, and then our last graph for this particular problem set, 1/3 times the absolute value of x. How did the function change from the parent function? So for this one, I might make a table so you understand it a little better. Okay. So we want to pick nice numbers for x that is a multiple of 3 so we can cancel it out. So I would pick negative, well, we don't have room for -9, but we do for -3. So it would be -3, 0, +3. Okay. So 0 times anything is 0. So 0, 0, same starting point. Let's do 3. If you replace 3 here, 1/3 of 3 is 1. Okay, if you replace -3, the absolute value of -3 is 3, and 3 times 1/3 is 1. So our graph is go left 3, up 1, go right 3, up 1. And then connect because we don't want to deal with fractions. So that's why I didn't pick fraction values for x. Okay, so if you've noticed this one, this graph is wider than the parent. It is wider. We use words like narrower or wider. So in the first one, or in problem B, I said stretch thinner. You could have said narrower. It is wider and less steep. The slope, again, I'll put in quotation marks, is positive or negative 1/3. Because we remember to find the slope, you rise over run. So from here, you would rise 1 and run 3 to the right to get to the next point. Right. Flipping. We are going to graph 3 more functions, starting with the parent. You're gonna love your short assignment tonight. All right. And there's your parent. Next one we're going to do is this time there's a negative number in front of the absolute value, whereas in the graphs above, they were both positive. So there's something to look forward to. So A and B are almost identical other than the negative sign. So I wonder what's going to happen. So we know the starting point is going to be the same. It's going to be 0, 0. Okay, replace 1 here. The absolute value of 1 is 1, but then you multiply it by negative 1. Because remember, this negative means it's negative 1. Anytime you have a negative and there's no number there, it's a negative 1. So 1 times negative 1 is negative 1. So we go right 1, down 1. Replace a 2 in there. 2 times negative 1, negative 2. So right 2. And you get the point. And then you do the same thing on the opposite side. The absolute value of negative 1 is a positive 1 times the negative 1 is negative 1. Right. Right. Well, I think this is pretty obvious. What has happened to that function compared to the parent? It has been reflected. That's the good word we want. Over the x-axis. Not the y-axis, but it's been flipped over the x-axis. Right. And the last one of our graphs before we come to a conclusion, a little summary. And then we'll do a couple of others, but it'll be the last of the comparing. All right. So for the last one, we have a negative 3, not a negative 1, but a different number. So negative 3 outside the x. How did the function change from the parent function? So replace it. It's still going to start at 0 because 0 times anything is 0. Replace a 1 in here. Its absolute value is 1 times negative 3. So y is negative 3. So write 1, down 3. And replace a negative 1 here. The absolute value of negative 1 is 1, and 1 times negative 3 is negative 3. So go left 1, down 3. And hopefully you noticed that this has also been reflected, but it's been stretched. So it has been reflected over the x-axis and stretched thinner vertically because it's skinnier up and down than it is wider. So it has been stretched thinner vertically. All right. Fill in the blanks to describe what effect A has on the graph. So now we're coming to a summary of what A did to those graphs on the back page. When absolute value of A is greater than 1, the graph is vertically stretched. And you saw that in part B on the very top. Because if I go back over here, this 3 right here is greater than 1. So, oh, I'm sorry. Yes. And it is thinner. What about the number in front of the absolute value is less than 1? Well, if it's less than 1, the graph is vertically shrunk and is wider. And for the flipping, if A is negative, the graph is reflected over the x-axis. It's a lot of information, but it's not too bad. And if you always go back to a table, you can see what a graph looks like. So for this particular graph, we have y equals the absolute value of x minus 3 plus 2. We are going to make a graph and write an equation from the graph for the last two examples. So the first one, we're going to graph it. And so we're going to identify the key features. We're going to start with identifying A. So A is the number in front of the equal sign. I'm sorry, is in front of the absolute value bar. And in this case, it'd be a 1. There's nothing here. There's always going to be a 1, right? And then H is in here. And remember, it's opposite. So this is what you have. So that tells you move right 3. And then K is 2. And that means you go up 2. So let's start with our vertex. So our vertex is HK, which is 3, 2. Once you have the vertex, it's clear sailing after that. So go right 3, up 2. So 1, 2, 3. And now you, because A equals 1, it hasn't been stretched. It's the same as the parent. So you just think of A as your slope. So it's just a 1-to-1 ratio, 1/1 ratio. All this graph did was it moved first 3 units to the right, up 2, and then it stayed the same like the parent. It's the same size as the parent. It's just been shifted right and up. The next one, write an equation for the graph. So the first thing we want to do is find the vertex. And so the vertex is right here. The vertex is actually supposed to be right on this. It just doesn't show it. So let's just put it right there at -1, 0. So notice this graph has been shifted left 1. So it's been shifted left 1. How do we represent that? Well, in absolute value, it's inside the bars. The right or left is with the x. But remember, it's opposite. So you put a +1 here. And then it has been reflected. So you know A is negative. How do you know what the number for A is? So, okay. And because of the negative sign. And then let's see what the slope is, and that'll tell you what A is. So the slope is rise over run. So from this point, let's see, here is the point right halfway in the middle. We go, or from that point, let's start at the vertex. So from the vertex, I'm going to draw a little triangle here. You go down 1, 1.5. So you go down 1.5. And you run just 1 to the right. And on the opposite side, you would go up 1.5 and run 1. But remember, because this graph has been flipped, A is going to have to be negative. So this would be, I'm going to write it as a fraction. So the equation is y equals negative 3 over 2 times the absolute value of x plus 1. Now, if I gave you the equation and I didn't give you the picture, you would get the same information. You would look at this number first and say, whoa, this is a positive 1. That means I go left 1. So my vertex would be negative 1, comma, and k would be 0. So because there is no up or down movement, that would have been our starting point. This is where we would start our graph, right here. And then the negative 3 means you go down 3, right 2. And the opposite way, you go down 3, you just go left 2. And that is it for our notes today. Have a great day, Algebra 2 students.